I'm so glad you found your way here tonight. Right now, even as you rest, your brain is quietly deciding what to keep from today, which moments matter, which feelings to soften, and which small details to tuck away in places you may never find again. Tonight, you'll discover how your sleeping mind sorts through the library of your life. And by the end, you'll understand why the night is not empty. It is the most quietly productive time your brain ever has. Welcome to Sleepless Scientist Night. Wherever you are right now, perhaps lying in the soft dark of your room, feeling the weight of the day beginning to lift from your shoulders, allow yourself this gentle settling. We'll journey through 100 calming mind facts about memory and sleep. From the moment your eyes close and your brain shifts into its private filing mode, to the deep architecture of dreams where old memories are rewoven into something new, to the quiet science of why you wake up feeling, sometimes, just a little bit different than when you lay down. This thoughtful journey through consciousness builds bridges between searching minds. A soft subscribe, like, or sharing your thoughts creates a pathway for more memory seekers to discover this space and brings us closer to protecting this sanctuary, one sleepy soul at a time. Your presence here tonight inspires everything we make. Thank you for being part of this. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain never truly rests while you sleep. For a long time, scientists believed sleep was a passive state, a kind of biological shutdown where the mind simply waited for morning. We now know the opposite is true. During sleep, your brain enters one of its most active and purposeful phases. Neurons fire in coordinated waves. Chemicals shift. Structures communicate across long distances. The sleeping brain is not resting. It is working, softly, methodically, and with a kind of intelligence that waking life never quite achieves. Sleep is, in the most literal sense, the brain's private working hours. The human brain holds somewhere in the tens of billions of neurons. Estimates currently range between roughly 60 and 100 billion, a range that reflects just how difficult the question truly is to answer. During sleep, the pattern of their activity shifts rather than quiets. Some regions become more subdued, particularly the prefrontal areas that govern focused, rational thought. Others begin a different kind of work, coordinated, inward, and purposeful in ways that waking never quite allows. What changes is not the presence of activity, but its direction. The sleeping brain turns away from the world and toward you. Memory is not a single thing. Scientists have identified multiple distinct memory systems in the human brain, each handled by different structures and serving different purposes. There is declarative memory, the kind you can speak aloud, like facts and personal events. There is procedural memory, the kind stored in the body, like how to ride a bicycle. There is semantic memory, which holds general knowledge, and episodic memory, which holds the story of your own life. Each of these systems is processed differently during sleep, in a carefully ordered sequence that science is only beginning to fully understand. The hippocampus is the first home of a new memory. Shaped like a small curved structure deep inside the brain, the hippocampus, whose name comes from the Greek word for seahorse, acts as a temporary holding space for recent experiences. When you learn something new or live through a meaningful moment, the hippocampus captures it quickly, like a photograph taken on the spot. But this storage is not permanent. Over time, and especially during sleep, memories must be moved to longer-term locations in the outer layers of the brain. The hippocampus is the beginning of the journey, not its destination. During waking hours, your hippocampus is constantly receiving new information. Every conversation, every sensation, every emotion adds to its temporary record. But the hippocampus has limited capacity. It cannot hold everything indefinitely. This is why sleep is not optional for memory. It is the biological window during which the hippocampus transfers what it has collected to the cortex, the vast outer layer of the brain where long-term memories are stored. Without this nightly transfer, new experiences would crowd out older ones, and the record of your life would slowly blur. Scientists use the term memory consolidation to describe the process by which fragile new memories become stable and lasting. Consolidation does not happen all at once. It unfolds in stages, across hours, and much of its most important work happens during the night. Research has shown that memories are measurably stronger after a full night of sleep than after the same amount of time spent awake. This is not simply because the brain is resting. It is because the sleeping brain is actively strengthening the neural connections that hold memories in place. Sleep does not simply preserve what was learned. It finds a quieter, more efficient path through the same material. One of the most meaningful discoveries in sleep science is that different stages of sleep serve different memory functions. Human sleep is organized into cycles of roughly 90 minutes each, and within each cycle, the brain passes through several distinct stages: light sleep, deep, slow-wave sleep, and rapid eye movement sleep, known as REM sleep. Each contributes something different to the process of memory sorting and consolidation. The brain does not simply sleep in one uniform way. It cycles through states as different from each other as water, ice, and steam. And each state does its own quiet work. Slow-wave sleep, sometimes called deep sleep or N3, is particularly valuable for declarative memory, the kind that holds facts and personal events. During this stage, the brain produces large, slow electrical waves called delta waves, which can be measured by instruments placed gently on the scalp. These waves are associated with the hippocampus replaying recent experiences and transmitting them to the cortex for long-term storage. If you explore something interesting before bed, slow-wave sleep is the stage that helps that knowledge find its permanent home in your mind. It is gentle work, invisible from the outside, but enduring. REM sleep, on the other hand, is associated with more layered memory processing, particularly emotional memories and the weaving of new information into existing knowledge. During REM sleep, your eyes move gently beneath your closed lids. Your brain produces electrical activity very similar to wakefulness, and most vivid dreaming occurs. Scientists believe REM sleep is when the brain does its most creative work, connecting distant memories, softening emotional edges, and weaving new experiences into the existing fabric of who you are. It is less like filing and more like editing, reshaping the story of your life into something coherent. The discovery that sleep stages serve distinct memory functions came largely from elegant experiments in which people were taught new skills or information, then either allowed to sleep normally or kept awake. Those who slept showed meaningfully better recall the following day, not just for facts, but for motor skills, emotional balance, and creative problem solving. Those kept awake showed significant memory degradation. This finding has been replicated across cultures, age groups, and types of learning. Sleep is not a passive partner to learning. It is the essential second half of the process. Without it, learning is incomplete. Your brain does not simply replay memories during sleep. It selects them. Not everything that happens in a day gets consolidated equally. The brain applies a kind of filter, prioritizing memories that are emotionally meaningful, personally relevant, or connected to things you care about. This selectivity has been observed in brain imaging studies, where scientists can watch which neural patterns are reactivated during sleep. The brain revisits the experiences that matter most, sometimes the same memory many times in a single night, strengthening its trace while allowing less meaningful events to fade softly into the background. Emotion is one of the strongest signals the brain uses to decide which memories to tend to. The amygdala, a small, almond-shaped structure located near the hippocampus, plays a central role in tagging emotional experiences for priority processing. When something moves you deeply or fills you with wonder, the amygdala flags that experience as meaningful. During sleep, the brain returns to these flagged memories with particular care. Interestingly, REM sleep appears to gradually reduce the emotional intensity of difficult memories while preserving their factual content, allowing you to remember what happened without being overwhelmed by how it felt. This emotional softening effect of REM sleep has been described by some researchers as a kind of overnight processing. The idea, supported by studies at several major universities, is that sleep allows you to revisit upsetting or stressful experiences in a neurochemically quieter environment, one where the stress hormone norepinephrine is at its lowest levels of the entire day. In this calmer chemical landscape, the brain can return to difficult memories without reactivating their full emotional weight, gradually reducing their charge. Morning, it turns out, brings not just light, but a measurable degree of emotional distance from the night before. People who are deprived of REM sleep show measurably greater emotional reactivity the following day. Brain imaging reveals that the amygdala becomes significantly more responsive after REM deprivation, reacting to unsettling images or stressful situations with far greater intensity than after normal sleep. This suggests that REM sleep is not a luxury but a biological necessity for emotional balance. The calm you feel after a good night's sleep is not imagined. It is neurological. Something has been adjusted in the night, calibrated, smoothed, and you wake into a slightly gentler version of the world. The brain also uses sleep to strengthen procedural memories, the kind that live in the body rather than conscious awareness. When you are learning a new skill, whether playing a musical instrument, mastering a new movement, or developing a craft, sleep is deeply helpful. Studies have shown that motor skills practiced before sleep are measurably more precise and fluid the following morning. even without additional practice. The improvement happens during sleep, not while you are awake. The brain rehearses what you learned, moving through the sequence again and again at the neural level, until the pattern becomes smoother, quieter, and more natural. This overnight motor consolidation has been observed in musicians, athletes, surgeons, and students learning new languages. In each case, the pattern is remarkably consistent. Practice, sleep, improvement. What is particularly interesting is that the improvement often exceeds what could be explained simply by rest. The brain does not just preserve what was learned, it refines it. It finds gentler pathways, releases unnecessary steps, and restructures the neural sequence into something more fluid. Sleep is not only maintenance, it is a quiet form of refinement. The role of sleep in language learning is especially well documented. During slow-wave sleep, the brain consolidates new vocabulary and grammatical patterns, and during REM sleep, it integrates these into existing language networks. Studies in which participants learned new words before sleep showed that those who slept retained and applied the vocabulary meaningfully better than those who stayed awake for the same period. This has practical implications for anyone learning a second language. The hours of sleep after a study session are not wasted time. They are, in a very real sense, among the most productive hours of the lesson. One of the more poetic discoveries in memory science is the phenomenon researchers call targeted memory reactivation. In carefully designed experiments, participants learned new information while a specific sound or scent was present in the room. When those same sounds or scents were played softly during subsequent sleep, too quietly to wake the sleeper, the memories associated with them were meaningfully better consolidated the following morning. The sleeping brain, it seems, can be gently guided. External cues whispered during sleep can subtly shape which memories are visited and strengthened. The mind listens even when we believe it has gone quiet. Dreams have long been associated with memory, and science is beginning to understand why. During REM sleep, the brain activates many of the same regions involved in processing real experiences. The visual cortex, the emotional centers, the areas responsible for narrative and meaning, all engage during dreaming in ways that closely mirror waking perception. What we dream is not random noise. Researchers have observed that the contents of dreams frequently reflect the concerns, experiences, and preoccupations of recent days, woven together with older memories in ways that suggest the dreaming brain is actively engaged in the work of integration. The relationship between dreaming and creativity has fascinated scientists for decades. REM sleep, with its characteristic blending of distant memories and loosened associations, appears to be particularly fertile ground for insight. Several studies have found that people are meaningfully better at solving problems requiring creative thinking, particularly those that need connecting seemingly unrelated ideas. After a period of REM sleep, the brain's reduced constraints during dreaming allow it to find connections that the more focused waking mind might overlook. Some of history's most celebrated insights have been attributed to dreams, a quiet reminder that the sleeping mind is not idle, but generative. The glymphatic system is one of the more remarkable findings in neuroscience of recent years. First described clearly around 2013, this network of channels runs alongside the brain's blood vessels and acts as a kind of fluid clearance pathway. During sleep, and particularly during deep, slow-wave sleep. The channels of the glymphatic system appear to expand, allowing cerebrospinal fluid to move more freely through the brain and carry away byproducts of the day's neural activity. Research published as recently as early 2026 has found evidence of this clearance in living human subjects, including molecules that accumulate in aging brains. The science is still developing, but its direction is consistent. The sleeping brain appears to tend to itself in ways the waking brain cannot. The glymphatic system has reshaped scientific thinking about why sleep is so biologically valuable. Research in animal models, and increasingly in human subjects using advanced imaging techniques, has found that this fluid movement is meaningfully reduced during wakefulness. The brain, it appears, cannot fully clear its own byproducts while it is busy processing the world. It requires the relative quiet of sleep to open its channels and allow the cerebrospinal fluid to do its work. What we used to call rest is, in part, one of the most thorough forms of renewal the body ever performs. The timing of memory consolidation within a night of sleep follows a specific pattern. Early in the night, slow-wave sleep predominates, and this is when declarative memories, facts, and personal events receive their most intensive processing. Later in the night, REM sleep becomes longer and more present, and this is when emotional memories, creative integration, and procedural refinement take center stage. A full night of sleep, therefore, provides a complete sequence of memory processing. Shortening sleep, even by just an hour or two, disproportionately reduces the later REM-rich stages, and with them, the emotional and creative dimensions of memory consolidation. Sleep scientists have documented a gentle phenomenon called sleep spindles, brief bursts of rhythmic brain activity that occur during the lighter stages of NREM sleep and last only about half a second to 2 seconds. Despite their brevity, spindles appear to play a meaningful role in memory consolidation. The frequency of sleep spindles on a given night is correlated with how well memories are retained the following day, with studies suggesting roughly 3 to 5 spindle events occurring per minute during deeper NREM sleep. These tiny electrical ripples, invisible and unfelt, are among the brain's most quietly productive moments. After 25 facts, a pattern has begun to emerge, and it is worth pausing gently here to feel its shape. The sleeping brain is not passive. It is not waiting. It is choosing, selecting, replaying, strengthening, clearing, and creating every night. Without your awareness or effort, the brain is tending to the library of your life, deciding what to keep clearly, what to soften, what to file deep, and what to let gently fade. The question that began our journey, how does your brain sort memories while you sleep, already has a partial answer. With extraordinary care, with quiet intelligence, and with a purpose far deeper than rest alone. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain thinking. All without your command. Right now, your hippocampus is already beginning its quiet work. Even in this moment of stillness, something is being filed. Something is being decided. Something is being kept. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. You don't need to do anything. Your brain knows what to do. Now we continue. Not all memories are treated equally by the sleeping brain. Research has revealed that the brain applies a biological weighting system that assigns priority to memories based on their perceived meaning, emotional charge, and connection to current concerns. A conversation that affected you deeply will be visited more often during sleep than a routine task completed without much thought. The brain, in its quiet efficiency, invests more consolidation effort where it matters most, which means that the memories you wake with most clearly are, in some sense, the ones your sleeping brain judged most worth keeping. The strength of a memory at the moment of encoding, at the moment you first experience something, influences how thoroughly the brain consolidates it during sleep. This is partly why vivid, emotionally engaging experiences tend to be remembered more clearly than routine ones. The initial encoding lays down a stronger neural trace, which the sleeping brain then has more to work with. Scientists have found that even naturally enhancing the encoding of a memory through emotion, novelty, or personal relevance leads to better sleep-dependent consolidation. The brain invests in what arrived fully. There is a window of vulnerability after a new memory forms, during which it is particularly delicate. In the hours immediately following a new experience, the memory exists in a fragile, temporary state, dependent on the hippocampus and easily influenced by new incoming information. Sleep, especially within the first night after an experience, provides meaningful protection during this tender window. People who sleep soon after learning show better retention than those who delay sleep, even if the total amount of sleep is eventually the same. The timing of sleep, not just its duration, matters for memory. Forgetting, it turns out, is not a failure of the memory system. It is an essential feature of it. The sleeping brain does not only consolidate and strengthen, it also gently prunes connections that are rarely used, experiences that are low in meaning, and the fine-grained details of ordinary moments are gradually softened during sleep, making room for what matters more. This selective forgetting is not loss, it is curation. The brain is not a perfect recorder of everything that has ever happened. It is an editor, shaping the archive of your life into something navigable, coherent, and personal. The concept of synaptic homeostasis offers one of the most compelling frameworks for understanding why we sleep at all. During waking hours, the brain learns, and learning strengthens synaptic connections, the tiny junctions between neurons through which signals pass. But this strengthening cannot continue indefinitely. Synapses that grow too strong become energetically costly and eventually saturate the brain's capacity for new learning. During sleep, the brain appears to scale back overall synaptic strength, preserving relative differences between connections while reducing the absolute level. This restores the brain's capacity to learn anew each morning. Sleep does not just file the past, it prepares for the future. The hippocampus and the neocortex, the large outer layer of the brain, communicate in a specific and coordinated way during sleep. During slow-wave sleep, the hippocampus generates sharp-wave ripples, brief, concentrated bursts of neural activity, which appear to trigger the reactivation of memory traces in the cortex. These ripples work in concert with the slower cortical oscillations and the sleep spindles mentioned earlier, creating a three-way dialogue between brain structures that allows recent experiences to be transferred and integrated. The sleeping brain is conducting a quiet orchestra, and the music it plays is memory. The transfer of memories from the hippocampus to the cortex is not instantaneous. It unfolds across multiple nights, sometimes over weeks or months. Each night of sleep adds another layer of consolidation, gradually making a memory more independent of the hippocampus and more firmly rooted in cortical networks. This is why memories of distant events, things that happened years ago, feel different from yesterday's experiences. They have been visited and revisited many times during sleep, becoming woven into the structure of the brain itself. The oldest memories are, in a sense, the most thoroughly processed. Scientists have used functional magnetic resonance imaging, known as fMRI, to observe the sleeping brain in real time. And what they have found is quietly extraordinary. During slow-wave sleep, regions of the brain that were active during a learning task earlier in the day show spontaneous reactivation, replaying their earlier patterns of activity in compressed, accelerated sequences. This replay has been captured most clearly in studies of spatial memory, where people who learned to navigate an environment show coordinated replay of their route during subsequent sleep. The brain walks the paths of the day again, in the dark, alone, tending to what it found meaningful. The relationship between sleep and memory accuracy is one of the more humbling corners of memory science. The same processes that consolidate true memories, the active reconstruction and integration that occurs during sleep, can also strengthen inaccurate recollections. Memory is not a recording, it is a reconstruction. Each time a memory is retrieved and reconsolidated, it is subtly open to modification. Details can be added, feelings can shift, the sequence of events can soften. Sleep does not make memories more accurate. It makes them more stable. And sometimes, what becomes stable is a version of events that has already drifted gently from what truly occurred. This reconstructive quality of memory has profound implications for how we understand our own past. The story you tell yourself about who you are, the narrative made of your clearest memories, has been revisited and reshaped by sleep many times over the course of your life. Each morning, you wake into a version of your history that is subtly different from the version you held yesterday. Not dramatically altered, but gently edited, with some edges softened, some moments brightened, some details quietly released. Memory, across a lifetime, is less like a photograph and more like a painting touched by many hands. Napping has been shown to provide some of the same memory benefits as a full night of sleep. In a gentler form, even a short nap of 60 to 90 minutes, long enough to include some slow-wave sleep, and in longer naps, some REM sleep, can meaningfully improve memory consolidation. Studies have found that participants who napped after learning performed comparably to those who had a full night of sleep, and better than those who stayed awake. The brain does not require darkness or 8 hours to begin its filing work. It begins the moment conditions allow. Age shapes how the brain consolidates memories during sleep. Children and adolescents experience proportionally more slow-wave sleep than adults, which may partly explain the extraordinary learning capacity of young brains. As we age, slow-wave sleep gradually softens, and with it, some of the efficiency of sleep-dependent memory consolidation. This does not mean older adults cannot consolidate memories, but the process may shift, requiring more sleep to achieve similar effects. Research into how to support slow-wave sleep across the lifespan has become one of the most active areas in sleep and aging science. Stress has a layered relationship with memory and sleep. Mild stress can actually enhance memory encoding. The brain's stress response increases certain neurochemicals that strengthen the initial formation of emotionally meaningful memories. But chronic stress disrupts sleep architecture, reducing slow-wave and REM sleep, and thereby interferes with memory consolidation. The brain, flooded nightly with stress hormones that remain elevated into the sleeping hours, cannot as easily enter the calm states it needs for its deepest memory work. Chronic stress, in this way, does not just affect how you feel, it quietly reshapes what you remember. Exercise has been shown to support sleep quality and, through better sleep, to enhance memory consolidation. Regular physical movement increases the amount of slow-wave sleep experienced each night and promotes the release of brain-derived neurotrophic factor, a protein that supports the growth and maintenance of neurons involved in learning and memory. People who move regularly show better memory performance and more restorative sleep architecture than sedentary individuals. The brain that moves during the day files more gently at night. The body and the mind are not separate systems. They share a single set of conditions. Partway through our facts about the middle portion of the night, a deeper picture of the brain's sleeping work has emerged. Memory consolidation is not one process, but many. A layered, staged, selective, and reconstructive system that uses the different stages of sleep for different purposes. The brain chooses what to strengthen. It chooses what to soften. It replays the most meaningful moments of your day in sequences too quiet for conscious awareness. It repairs, prunes, integrates, and prepares. And it does all of this in the gentle hours when you believe nothing is happening. When you believe you are simply, peacefully, asleep. You're still here, thoughts still drifting like half-remembered dreams. Just notice how different your mind feels from when you began. Something has shifted, softened, perhaps. We're moving through the library of how memory is made together, in the quiet dark. Each fact, a gentle footstep deeper in. Let's continue. The experience of waking with sudden clarity. Having the solution to a problem you puzzled over the night before has a name in sleep science. It is sometimes called sleep-dependent insight. Studies have found that people are measurably more likely to discover hidden patterns or solutions to layered problems after a night of sleep than after an equivalent period of waking thought. REM sleep, with its characteristic loosening of associative boundaries, appears to be particularly valuable for this kind of insight. The sleeping brain finds connections the waking mind could not. It sees the pattern from a distance the daytime cannot reach. One well-known experiment on sleep-dependent insight presented participants with a mathematical task that could be solved laboriously through a step-by-step procedure, or more fluidly through a hidden shortcut that had to be independently discovered. Those who slept were considerably more likely to find the simpler path, the one hiding in plain sight, just beneath the surface of the problem. The sleeping brain had found the gentler route. This finding has been replicated and extended in multiple studies. It suggests that sleep does not merely preserve what we know. It transforms how we know it, creating new understanding from the same quiet material. The practice of sleeping on a difficult decision is widely recognized in everyday life, and neuroscience increasingly supports its value. When a complex decision is left unresolved before sleep, the brain's offline processing during the night appears to integrate relevant information, weigh emotional factors, and sometimes arrive at a clearer perspective by morning. This does not mean the sleeping brain makes decisions for us, but it does seem to prepare the neural ground for more considered decision-making upon waking. The advice to sleep on it is not folk wisdom dressed in experience. It reflects something real about the brain's nocturnal work. Memory and identity are deeply intertwined. The story of who you are, your sense of yourself as a continuous person across time, is constructed from your memories, and those memories are shaped every night by sleep. The self you wake up as is not identical to the self who lay down to sleep. Some small part of yesterday has been processed, softened, or more firmly placed. Some old memory has been quietly revisited and perhaps subtly revised. This is the normal and necessary work of a living brain. The self is not a fixed thing. It is a story being written every night, in the dark. Post-traumatic stress offers a revealing window into what happens when sleep-dependent memory processing is disrupted. In individuals who have experienced trauma, the normal REM sleep process of emotional processing can be interrupted, contributing to the intrusive, vivid re-experiencing of difficult events that can characterize the condition. The memory has not been processed in the usual way. It has not had its emotional charge gradually reduced through repeated, gentle overnight revisiting. Understanding this has led researchers to explore sleep-based approaches as a potential avenue for supporting trauma recovery, working with the brain's natural overnight processes rather than against them. The most resilient memories are the ones distributed most widely. Different aspects of a single memory, its emotional tone, its contextual associations, its narrative meaning, are held across multiple cortical regions and linked together into a pattern of connections rather than a single fixed location. This distributed architecture is what makes memories endure. Damage to one area of the brain may soften one aspect of a memory while leaving others intact. What feels like a single, unified recollection is actually a constellation. Scattered fragments the brain assembles, at the moment of retrieval, into something that feels whole. Sleep, across many nights, deepens and widens that constellation. Sleep-dependent memory consolidation does not operate in isolation from the rest of the brain's chemistry. Adenosine, a chemical that accumulates in the brain during waking hours and gently drives the pressure to sleep, gradually clears during sleep. The timing of sleep is also regulated by the brain's internal clock, the circadian system, anchored in a tiny structure called the suprachiasmatic nucleus, which coordinates the brain's sleep-wake cycle with the light and dark of the external world. Memory consolidation is most effective when sleep occurs at the right phase of the circadian cycle. Even the timing of when you sleep shapes what you remember. Caffeine, which works by blocking adenosine receptors, can disrupt sleep architecture when consumed in the afternoon or evening, reducing slow-wave sleep and fragmenting the overnight memory consolidation process. Alcohol, though it may initially promote drowsiness, similarly disrupts sleep, particularly suppressing REM sleep in the second half of the night, when emotional and creative memory processing reaches its fullest expression. These chemical effects on sleep architecture translate directly into effects on memory. What you place into your body in the hours before sleep shapes what your brain can do with the memories of your day. Researchers have begun to explore how sound influences sleep-dependent memory consolidation. Building on the discovery of targeted memory reactivation, studies have investigated whether specific auditory cues, played softly during slow-wave sleep, can improve the consolidation of corresponding memories without waking the sleeper. Results have been encouraging. Participants who learned word pairs while specific tones played, and who then heard those tones quietly during subsequent sleep, showed better memory for those specific pairs. The sleeping brain is responsive to the world, more open, more available to gentle influence than we once believed. We are now at the midpoint of our journey, and the question that opened this night has begun to answer itself. Slowly and with increasing depth, the brain sorts memories while you sleep through a remarkable, layered architecture of processes: selective replay and reactivation, hippocampal cortical dialogue, emotional processing in REM, skill refinement in slow wave, gentle fluid clearance, synaptic scaling, and the patient, persistent work of consolidation that continues across every cycle of the night. It does this in silence, automatically, with a level of care and purpose that no waking effort could replicate. And it does it tonight, right now, as you drift closer and closer to the place where its work begins. Let each breath guide you to realize time is yours, a separate stream that only you are living. Every memory your brain has ever kept was formed in a specific moment. Irreplaceable, unique, belonging only to you. The brain working softly tonight is the same brain that encoded your earliest clear memory. It has been doing this work for your entire life. Filing, sorting, keeping, releasing. Allow yourself to rest in this present moment, knowing that right now, your brain is tending to it with care, and we continue drifting. Memory is intimately linked to place. The hippocampus contains specialized cells called place cells, which fire in response to specific locations in the environment, creating an internal map of space. During sleep, these place cells replay the routes and locations experienced during the day, sometimes in the same sequence, sometimes in reverse, sometimes in compressed or rearranged form. This spatial replay is one of the clearest demonstrations that the sleeping brain is actively rehearsing experience. The brain walks the paths of the day again, in a stillness of its own making. There are memories so old, they have become part of the structure of who you are, so thoroughly consolidated across decades of sleep that they are no longer dependent on any single brain region. These remote memories are distributed across the cortex in a way that makes them deeply resilient. Even significant hippocampal damage, which can severely affect the formation of new memories, may leave remote memories largely intact. The oldest parts of your story are the most deeply written, visited so many times during sleep that they have become, in some sense, the architecture of your mind itself. The boundary between a memory and an imagination is thinner than most people realize. The same neural systems that construct memories also construct imagined futures and fictional scenarios. The hippocampus, which holds the pieces of past experiences, is also recruited when we imagine events that have never occurred. This shared architecture suggests that memory is not primarily about the past. It is a flexible simulation system, evolved to model possible futures using the material of lived experience. Sleep, which extensively processes both memory and imagination, may be one of the primary ways the brain prepares itself for what is yet to come. The content of your dreams is not random, but it is not a simple replay of the day either. Studies using careful observation of what people experience during waking hours, followed by dream diaries, have found that dream content tends to reflect concerns, themes, and emotional preoccupations, rather than specific events. The technical term is the day residue effect, and it operates with a characteristic time delay. Dreams are more likely to incorporate elements from 2 to 7 days before the dream than from the immediately previous day. The brain seems to be working something through, not just filing it, but returning to it until it finds a resting place. The sleeping brain is capable of a kind of pattern recognition that conscious thought finds difficult. During REM sleep, when the prefrontal cortex is relatively quiet and the associative areas of the brain are more active, connections between distant memories can form freely. The brain is less constrained by the logical filters that govern waking thought, allowing it to find similarities and patterns across experiences that seem unrelated on the surface. This is why dreams can feel layered, symbolic, and rich with something that resembles meaning, because they are the products of a mind making connections without its usual rules. Sleep plays a role not only in consolidating memories, but in allowing them to be generalized. When you learn something specific, how to navigate a particular task, for example, sleep appears to help the brain extract the underlying principle and apply it more broadly. This generalization means that a skill learned in one context becomes more flexibly available in others after sleep. The brain does not just remember what you did, it begins to understand why it worked. And understanding, unlike mere recall, transfers across situations in ways that serve you long after the original experience has softened. The relationship between sleep and memory changes across the lifespan in ways that reflect the changing needs of the brain. In infancy and early childhood, when the brain is absorbing language, movement, and social interaction at a remarkable rate, sleep occupies a far greater proportion of the day. Newborns sleep up to 18 hours. The proportion of time spent in REM sleep is also higher in infants, perhaps reflecting the intensity of the brain's need to integrate the flood of new experience arriving in those early months and years. In adolescence, the timing of the circadian clock shifts, making it biologically natural for teenagers to fall asleep later and wake later than adults. This shift, driven by changes in the circadian system during puberty, has been observed across cultures and is not simply a social habit. It means that early school start times can place adolescents in a state of chronic sleep reduction during some of the most formative years of their brain development. The consequences for learning and emotional balance are measurable and worth understanding. The sleeping brain is particularly sensitive when its natural timing is misaligned with the demands of the waking world. Lucid dreaming, the state in which a sleeper becomes aware that they are dreaming while remaining asleep, offers a rare window into conscious experience during REM sleep. Brain imaging studies of lucid dreamers show distinctive patterns of activity in the prefrontal cortex not present during ordinary dreaming, suggesting that self-awareness can emerge even within the sleeping brain. Lucid dreamers have been able to communicate with researchers using prearranged eye movements during sleep, confirming their conscious awareness. This gentle state, aware but asleep, thoughtful but dreaming, blurs the boundary between the sleeping and waking mind in ways that science is still working to understand. The experience of déjà vu, that quiet sense of having been somewhere or experienced something before, when you know rationally that you have not, may be partly related to memory processes. One influential theory proposes that déjà vu occurs when the brain's familiarity detection system activates without the accompanying recollection of why something feels familiar, perhaps because a current experience closely resembles a forgotten memory, or because partial pattern matching triggers a sense of recognition without a retrievable source. It is, in some sense, the filing system misfiling, and then noticing its own mistake in real time. Sleep reduction creates a subtle but meaningful distortion of memory confidence. People who are significantly sleep deprived do not simply remember less. They can become more certain about incorrect memories. Studies have found that tired participants are more open to misinformation, more likely to accept false suggestions about events they witnessed, and more likely to report memories of things that did not happen. The fatigued brain, lacking the resources to carefully evaluate the source and accuracy of its own recollections, fills gaps with plausible-seeming alternatives, and then believes them. Sleep protects not just memory, but the quiet accuracy with which we hold it. The interaction between memory and smell during sleep is one of the more intimate aspects of the brain's nocturnal work. The olfactory system, responsible for processing scent, has unusually direct connections to the hippocampus and amygdala, which is why scents so readily evoke memories and feelings. During sleep, gentle odors have been shown to facilitate memory consolidation through targeted memory reactivation. A familiar scent, drifting softly through the air during slow-wave sleep, can strengthen memories associated with it without disturbing the sleeper. The night, even in stillness, is not without influence. Temperature plays a role in the quality of sleep and the gentleness of memory consolidation. The brain's temperature naturally decreases during sleep, part of the body's preparation for the slower metabolic state of deep sleep. A cool sleeping environment supports this natural cooling, supporting the architecture of slow-wave sleep. Studies have found that sleeping in environments that are too warm can disrupt sleep staging and reduce the time spent in restorative deep sleep. The conditions of the sleeping body are not incidental to the brain's work. They are part of the quiet context in which that work occurs. Meditation and stillness practices have been found to influence sleep quality in ways that may also support memory consolidation. Regular meditators show measurable differences in sleep architecture compared to non-meditators, including more time in slow-wave sleep and changes in sleep spindle patterns. Long-term practice has also been associated with changes in hippocampal structure. These findings suggest that practices that calm the waking mind may also support the brain's capacity for overnight memory work, perhaps by reducing the elevated cortisol and nervous system activation that can interfere with the deep sleep stages most valuable for consolidation. There is growing evidence that the sleeping brain is capable of a limited but genuine form of learning, even during sleep itself. Studies have shown that participants can acquire simple associations between sounds and mild sensations during sleep, and retain those associations upon waking. The sleeping brain is not simply a passive organ. It can respond to its environment, form basic connections, and make those connections available to consciousness. The boundary between sleep and wakefulness is not a wall, it is a gradient. And the brain does not fully stop its learning work simply because the eyes have closed. The brain's default mode network, a set of connected regions most active during mind wandering, self-reflection, and the weaving of autobiographical information, shows a characteristic pattern of activity during REM sleep. This network, which includes regions of the prefrontal cortex and the medial temporal lobe, is involved in the construction of personal narrative, the ongoing story of who we are. Its activity during REM sleep may be partly why dreaming so often involves the self, why dreams feel personally meaningful even when they are strange, and why the night seems to be, in some deep sense, when the brain tends to the work of being a person, memory and social connection are deeply linked. Studies have found that memories formed in the context of social interaction, conversations, shared experiences, observed emotions, are often more durably consolidated than memories formed in isolation. The social brain and the memory brain overlap substantially. During sleep, socially meaningful memories receive particular attention, perhaps because social information has been throughout human evolution among the most consequential a brain could hold. The person you spoke with today, the feeling of being understood, the kindness of an unexpected gesture, these are among the memories your sleeping brain tends to keep most carefully. The concept of memory reconsolidation, supported by both animal research and increasing human evidence, suggests that each time a memory is retrieved, it briefly re-enters a more open state in which it can be gently modified before being stored again. This means that the act of remembering is also, subtly, an act of rewriting. Sleep following memory retrieval appears to facilitate this reconsolidation process, stabilizing the updated memory in its new, slightly changed form. The implication is both humbling and strangely hopeful. The brain's relationship with the past is never quite finished, and every memory has the potential, across a night of sleep, to become slightly more bearable than it was. Researchers have found that the emotional tone of memories can be selectively softened during sleep. The factual content of a memory tends to be preserved more reliably than its emotional charge. This means that, over many nights, you can remember that something difficult happened, and remember it accurately, while the visceral emotional weight it once carried gradually becomes less immediate. This is not suppression or forgetting. It is the brain's gentle management of the past, preserving what is useful to know while softening what no longer needs to be felt so intensely. Sleep, in this sense, is a quiet form of mercy. The neuroscience of memory has revealed something quietly meaningful about the nature of the past. What we experience as memory, that vivid sense of returning to a specific moment, is not a retrieval of stored footage. It is a reconstruction, assembled in real time from scattered neural fragments, shaped by our current state and beliefs, colored by everything that has happened since. Every act of remembering is, to some degree, an act of creation. The past, as we experience it, is always being made in the present. Sleep is one of the primary places where this making happens. Without our knowledge, in the hours when we believe we are nowhere at all, the hippocampus communicates with the cortex through a signal called the sharp wave ripple, a burst of high-frequency neural activity that lasts only a fraction of a second but carries a rich cargo of information. During slow-wave sleep, the hippocampus produces concentrated bursts of these events. each one a brief surge, carrying compressed replays of the day's experience to the waiting cortex. In active periods of deep sleep, dozens of these events can occur within a single minute, each one advancing the transfer of memory from its temporary home towards something more lasting. Scientists monitoring these signals have been able to predict, with measurable accuracy, which memories a sleeping participant will later remember. The replay is real, the transfer is real, and it happens in ripples too brief and silent for the sleeper to ever sense. Sleep and imagination share neural infrastructure in ways that suggest they evolved together. The ability to mentally simulate events, to imagine what might happen, to plan, to anticipate, requires many of the same brain structures used in episodic memory. The hippocampus, the medial prefrontal cortex, and the posterior parietal regions are all involved in both remembering the past and imagining the future. Dreams, which recruit all of these systems, may be the brain's nightly exercise in simulation, running through possibilities, rehearsing emotional responses, and preparing the flexible, forward-looking mind for tomorrow's world. The words we use to describe our memories shape the memories themselves. Research on verbal encoding has shown that labeling an experience with language, putting it into words, either aloud or silently, changes how it is stored in the brain. Verbal encoding engages different neural regions than purely sensory or emotional encoding, and tends to make memories more integrated with existing knowledge. During sleep, these verbally encoded memories may be woven more readily into the brain's existing networks. Language does not just describe memory, it shapes the form memory takes. As we approach the deepest phase of our journey tonight, the picture of the sleeping brain's memory work has become something like a landscape seen from a gentle height. Below, in the detail, are the sharp wave ripples, the sleep spindles, the REM cycles, and their loosened associations. But from this height, the pattern is simpler and more beautiful. The sleeping brain is tending to you, to the specific, irreplaceable, accumulating story of your days. Every night it receives the raw material of your waking hours and does its best to make something lasting from it. Every morning you wake into a slightly different version of who you were, shaped in ways you will never fully trace, by what the night decided to keep. By now, the answer to our opening question has arrived in full. Your brain sorts memories while you sleep through an intricate and coordinated system of replay, transfer, consolidation, emotional processing, creative integration, and selective softening. It uses the distinct stages of sleep as different instruments in this process. Slow-wave sleep for facts and places. REM, sleep for emotions and creativity. Sleep spindles for declarative memory. Sharp-wave ripples for hippocampal transfer. It weighs meaning, applies emotion as a signal, replays the moments that mattered, and softens the ones that no longer need their full intensity. It does this every night. It is doing it right now. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath. Inhale. Exhale. Your heart. Beat. Rest. Beat. Your sleep cycles. Light. Then deep. Then dreaming. Then light again. All are rhythms. Verity. Gentle returns. you are also part of that eternal movement. The brain, now beginning its deeper work, does not need you to be awake for it. You don't need to hold on to anything. Let everything unfold in its own order, like a tide that does not strain to reach the shore, simply arriving, as it always has. We're almost there now. Every night contains multiple opportunities for memory consolidation. The first sleep cycle begins within minutes of falling asleep. Each cycle lasts roughly 90 minutes. A full night offers 4 to 6 complete cycles. Each cycle adds something different to the accumulating work of the night. Missing even one cycle changes what the morning brings. The brain knows which memories you care about, not through logic, through feeling. The things that moved you today, even softly, even briefly, carry a marker. That marker guides the night's work. Emotion is the brain's compass for what deserves keeping. Dreaming may be the closest the brain comes to play. In dreams, the usual rules relax. Unlikely combinations become possible. Old faces appear in new places. The strict order of time dissolves. This is not confusion. It is a kind of freedom. The dreaming brain is exploring what waking life does not allow. The hippocampus is active even during quiet waking rest. When you pause, when you sit in stillness, when you let your mind wander, memory consolidation continues. Not as fully as during sleep, but meaningfully. The brain uses every moment of quiet it is given. A single night of poor sleep is enough to subtly affect memory the following day. Not profoundly, but noticeably. The words that come more slowly. The name that hides just out of reach. The sense that something learned yesterday is less clear than it should be. The brain is honest about what it needs. Sleep also tends to memories of kindness. The moments when someone helped you. The feeling of being understood. The warmth of a conversation that went somewhere unexpected. These emotional memories receive care during the night. They are among the things the brain decides to keep most gently. The memories that soften most with age are not random. Episodic memories. Specific events. Particular days. Personal experiences tend to become more delicate first. Semantic memory, general knowledge, language, understanding, tends to be more enduring. The brain protects what it considers most universal. The personal, the specific, the once-in-a-lifetime. These require the most careful tending. Your earliest memories. Those fragments from childhood before the age of 3 or 4 were formed before the hippocampus was fully mature enough to consolidate them into lasting form. This is why so few of us can clearly recall the first years of life. Not because nothing happened, but because the brain that would have kept those records was still being built. The system that files the story came after the story had already begun. Memory and meaning are inseparable. The brain does not simply store events. It stores events in relation to other events, layered with context, feeling, and significance. A fact learned in isolation is harder to keep than a fact woven into a story. A moment experienced with full attention is remembered more vividly than one passed through without noticing. The depth of memory is, in part, the depth of the presence that created it. Some memories exist only in the body, the quiet tightening in the chest before a difficult conversation, the softening of muscles in a familiar place, the subtle shifting of breath in the presence of something beautiful. These procedural, somatic memories are among the oldest and most durable. held not in words or images, but in the body's learned responses to the world. Sleep tends to these too, in its own quiet way. Sleep is not a pause in the story of who you are. It is one of the places where the story is written. The brain that processes memories during sleep is the same brain that will shape thoughts, feelings, and responses tomorrow. What the night keeps becomes the material from which the next day's self is partly made. Every morning you wake into a version of yourself that the night has gently touched. Memory research has found something softly reassuring. People who approach their memory with patience, who trust it to do its best, who allow for imperfection without judgment, tend to navigate, recall more gently. The brain is responsive to the stories we tell about it, treating memory kindly, expecting it to serve you well, trusting the night's work. These attitudes are not merely comforting. They may, in their small way, reflect something true. The brain creates entire worlds while you sleep. Every night, during REM sleep, the mind constructs vivid experiences from memory fragments, feelings, and abstract patterns. Our characters appear, conversations unfold, and landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and the faintest physical sensations. Yet they dissolve upon waking. Like morning mist, the sleeping brain is not resting. It is creating the memories that feel most yours, the ones that seem to define who you believe yourself to be, have been visited by sleep more times than you can count. They have been returned to, gently reshaped, and more firmly placed across hundreds of thousands of nights. What feels most stable and personal in your sense of self is also, in a way, what has been most thoroughly tended by the dark. The most deeply held self is the most thoroughly remade one. So how does your brain sort memories while you sleep? It has been doing so your entire life. From the first months of infancy, when sleep occupied more of your hours than waking, to this very night, this very moment. The system is ancient, elegant, and personal. It was built for exactly this purpose: to take the raw material of your days and transform it, gently and without your awareness, into something that will last. Tonight, as you lie here, your hippocampus is already beginning to replay the day. Not all of it, not without care. The moments that mattered most, by whatever measure the brain applies, are being visited first. They are being held softly in the light of the brain's attention, then transferred, carefully, to the quieter and more permanent structures of the cortex. The conversations of today are being sorted. The feelings of this afternoon are being processed. The small moments of beauty or connection or difficulty that you moved through without fully stopping. Some of these, the brain has noticed. It is tending to them now. The mind that will wake tomorrow has already been shaped by tonight. Not dramatically, not all at once, but something from today will be more firmly held. Something difficult may feel slightly less sharp. Something learned may be more readily available. The night is not neutral. It is working. Memory is not what happened to you. It is what remained after sleep decided what to keep. It is the edited version of your days, selected for meaning, softened where needed, strengthened where it serves you, and slowly, over a lifetime of nights, woven into the fabric of who you have become. The brain does not need you to be awake for this work. It does not need your supervision, your effort, or your understanding. It only needs the conditions you are providing right now. Stillness, darkness, the slow deepening of breath. You have already done the most meaningful thing. You came here and lay down. The rest belongs to the night. And so, our gentle journey through the sleeping brain comes to a soft close. We traveled from the first fragile moment of a new memory forming in the hippocampus to the deep and coordinated exchange between brain structures in the silent hours of the night. We discovered that slow-wave sleep and REM sleep each carry their own distinct gifts, one tending to facts and places, the other to feelings and connections and the quiet blending of distant things. From the delicate rhythm of sharp-wave ripples carrying the day's most meaningful moments toward the cortex, to the slow and patient work of sleep spindles strengthening what was learned, we glimpsed how the sleeping brain is always doing something. Something for you. Something on your behalf. The night, we learned, is not empty. It is one of the fullest, most purposeful, most personally devoted things the brain ever does. Memory reminds us that the past is not simply behind us. It lives forward, shaped and gently remade each night into something that serves the person we are becoming. Much of this most intimate work happens in the deepest silence, in waves too slow to feel, in ripples too brief to sense, in the soft chemistry of a brain that does not stop caring for you even when you have stopped paying attention. Without the night's tending, experience would accumulate without meaning. By pausing to understand what happens in the dark, we glimpse the extraordinary devotion of a brain that has been, all along, on your side. In these final minutes, take the deepest breath you can. As deep as possible, think about unity, of every memory that has ever formed in you, every night that has ever tended to you, every morning that brought you back. Slightly different, slightly further along. You are not separate from this process. You are it. The memory and the one who holds it, the night and the one who rests inside it, the brain sorting and the person being sorted. Gently, carefully, with no effort required from you at all. Think about consciousness itself, yours, and the awareness of everyone lying in the dark tonight, in every time zone, in every kind of room, on every kind of bed, all of them being tended to, all of them receiving the same quiet gift. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep. No boundaries left, only peace. If this gentle journey through the sleeping mind helped you relax or drift a little closer to sleep tonight, perhaps share it softly with someone else who lies awake, turning their thoughts over in the dark. It might be exactly the company they needed. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, farther than most journeys take you. You can allow these thoughts of memory and sleep to fade now, like the last image of a dream dissolving at the edge of waking. Present, then softer, then simply part of everything, leaving only the quiet calm behind. Let your breathing deepen. Let your body feel heavier, as if the gentle weight of all tonight's understanding is settling softly into you, and is simply, peacefully, holding you. If sleep comes, let it carry you the way the brain carries memory, without force, without effort, but with quiet intention, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your brain will still be there, still sorting, still keeping, still weaving today into the larger story of who you are. Memory will still be forming, consolidating, becoming. But tonight belongs to stillness. Rest well, sleepy soul, and remember, every night, without fail, your brain is tending to you. Good night.